Alrighty, welcome back, boys and girls. It's your main math man, Mr. Shank, coming to you live from Walker Grant Middle School. And I want to make sure that we have some main ideas for that SOL 8.3. And so this is the one that you were trying to do two things. You want to estimate and determine the two consecutive integers between which a square root lies. And you want to be able to determine the positive and negative square roots of a given perfect square. So let's break it down one thing at a time. So when you're talking about two consecutive integers, a lot of people get caught up on this word right here. They're not used to the back-to-back, two-time, multi-champion consecutive ideas. So it's back to back, or if you are a little bit more mathematical like myself, you can think it's a sequence, meaning it's the next one in sequential order, or it is the one directly after it. And so when you're, an example of this would be, if I'm thinking of, all right, 8.3, well, will be the next, or let's say, if we're counting, I'm going to say some two consecutive integers will be, well, when you go from 7th grade, you go up to 8th grade, assuming you pass all of your classes. And so these would be two examples of two consecutive integers. So now, how do we figure out what a square root lies between? Well, if we were to use the example, let's say, if we had the negative square root of 23. Well, let's use our wonderful Desmos calculator to figure out where we're at on here. So we're going to say, all right, the negative square root of 23. It gives you this crazy number, but we can at least give it the first couple decimal places. So we have negative and 4.79. All right, that kind of gives me an idea of where I am at. Make sure you're thinking, okay, where am I at? What are the two consecutive integers this falls between? Well, if I'm thinking on a thermometer, I'm thinking, okay, what would be the next whole number, or the next integer that would go down? So I would think, okay, it's going to be negative 5 is going to be my 1. And then, well, what is the, if I keep going up now, and maybe it gets a little bit warmer, I'd be at negative 4. Again, a lot of people, the common mistake that people are making, they're saying that this is going to be 3 because they're used to seeing 3, 4, 5. However, it's talking about consecutive integers, because your answer would be these two values. You would say the square root of negative 23 falls between negative 4 and negative 5. If you are saying two values that are not consecutive, you know you are going to be in the wrong place. Make sure also that if you're thinking on a number line, you think, okay, where am I at? Well, I'm below 0, so I'm talking about these values to the left. And so I have, let's say, 1, 2, 3, 4, 5. This is going to be negative 4, and this is going to be negative 5. And I think, okay, let's use that benchmark of 4.5. Again, I use right in the middle. I know this is going to be 4.5. And so I'm going to be a little bit to the left. So I'm going to be approximately right in here is going to be that negative square root of 23. Be able to place those values on a number line and have that as two consecutive integers. Now that second part that we have for this, we want to be able to determine a positive and negative square root of a perfect square. So again, a perfect, let's say a perf square. What are we talking about? Well, when you take a square root of a value, let's say 169, you usually think, okay, boom, 13, I'm good to go. However, we also know that this could be negative 13. And well, let me prove this. We know that, okay, 13 squared can be displayed as 13 times 13, which is 169. And I know a lot of you are going, okay, Ms. Shank, we know. However, think about this. 13, the negative 13 squared is displayed like this. We have negative 13 times itself, which is also 169. So you want to make sure that you could have this or in here. Again, that perfect square is when you have a square root that is an integer. Again, use those key real number subsets for yourself. So again, being able to have those perfect squares, we covered that at the beginning of the year. Again, very simply, it's just those amounts as follows. So you can have 1, 4, 9, 16, 25, so on and so forth. Again, notice how the pattern goes. You were saying that the square root of 1 is an integer. The square root of 4 is, let me bump this up, the square root of 4 is an integer. The square root of 9 is an integer. So again, notice how that works as you are taking the square root of a number. If that square root ends up being an integer, it is a perfect square.